Good morning. It is great to be back. Was this the third VBSD Con? Thank you so much for doing this. I greatly appreciate that. My name is Michael Dexter, and I will be talking about isolated BSD build environments using virtual and hardware machines. I wear a few hats, as Glenn alluded to. I provide support through my own organization and some work with hypervisors. I work as the IX System Senior Analyst, and that keeps me busy with OpenZFS and FreeNAS, and you may have seen some of my articles on that. And increasingly, I've been busy with SNIA, the Storage Industry Networking Association. They are a standards body. They're responsible for things like Fiber Channel and other exciting things that you've either heard of or never heard of. So you've probably heard me talk about hypervisors, and hypervisors are great. They're exciting, very useful technology. But with my work with SNIA, I'm working with some amazing storage professionals looking at the risks to your data and the best practices and not so good practices out there. Do watch for a white paper we'll be publishing soon. Are you protected from bit rot? And fortunately, those in this room are a little more aware than most about some great solutions to mitigate bit rot, ZFS. But ransomware is on the rise, and various organizations worry about e-discovery and combat the interests of long-term backup versus keeping the bare minimum information around should you ever be subject to e-discovery. And based on this work, I've concluded that some of the top pressing issues in storage are best addressed with hypervisors. Who'da thunk? So three top categories appear to me. The first is feature augmentation. Show of hands, is everyone familiar with the Beehive hypervisor on FreeBSD? A great many of you are. It is a in-base, permissively licensed hypervisor. It came from a storage vendor and was pretty much inspired by Meet BSD conference participation a few years back. Now, the storage vendor, like any good vendor, would acquire companies and products. And when your acquisition is based on a different platform, you want to get it on your platform as quickly and easily as possible. And you could maybe port it for, say, 6 to 12 months, or you can slam it in a hypervisor and the customer will probably never know, the user. So that's becoming exciting, and if you've been following FreeNAS, you'll see that it is sprouting virtualization features and has been pretty steadily. The second is backup validation. Now, in the good old days, you'd collect lots of backups on tape and pray that Schrodinger's backup will be there when you need it. And in talking to professionals, we're now entering a world where your database is in a VM on who knows what, and you have buffer caches flying by every which way, and synced to disk now can mean a great many things at a great many levels. But when you, say, enter the world of online storage with ZFS, and you have an OS with a built-in hypervisor, you can do smoke tests of your backups anytime, any place. If it's a database in a VM, you could probably boot it read-only, take a peek at the database, and just do a simple query to determine if it's intact or if it's garbage. So that's, I think, something we'll see more of, because Schrodinger's backup is not something any of us should face, because when you need it most, it's probably not going to work. Plus some Murphy's Law there. And finally, regression hunting. So this kept me busy for a good 9 months. It's a bit of a murder mystery. And let's see, some of you are familiar with this, some of you are not. So the facts are that Samba SMBD on FreeBSD was slaughtered in performance somewhere between FreeBSD 9.3 and 10.0. For those users with, say, let's just say as low as 1,000 files on up, so anywhere in that nice sweet spot, between 1,000 and 1,000,000 files, it would fall over. And it was not obvious why. So the victims of this event, this little surprise, were those with electron microscopes photographing the little CPU wafers every few seconds and slamming over to their storage array using their legacy app. And they couldn't re-architect it in a hurry. They couldn't nest files in directories, which is a good practice on any operating system. And those counting lumber as it flew by in the factory, they were finding that, whoa, this is tipping over, and that old XP box in the recycling bin is outperforming our FreeBSD awesome array with Xeon processors and beautiful RAID 10 ZFS array. So we had a problem. And so all I knew was that the problem occurred between FreeBSD 9.3 and 10.0. Now, looking at the SVN revision tags, that's only a mere 7,734 plus or minus commits apart. So there is a needle in that haystack that we need to find, and find it quickly. So who done it? Got to figure that out. This should take an afternoon. Hey, no problem. I'll just set time aside and sit down and work out what's going on because, hey, got to get back to my day. And so I started doing what any responsible sysadmin does, which is blame Samba. It is a very complex piece of code. If you look at the list of man pages, there are 80 or so utilities that represent Samba. It's chasing a cryptic de facto standard. Let's hear it for documented open standards. And it's legendary in its complexity. So that was my first impressions, like that must be the guilty party. So I spun up some FreeBSD 9.3 boxes and 10 boxes and did some simple testing. Thought, okay, just throw some files at it, just get a feel for what might be normal, what might not be. And then found that I had to get a little more consistent with my testing, and you run it by an engineer, and they're like, well, you know, your pool configuration could have massive, impact on what results you get. And I start adjusting all of the standard Samba variables and chase the tribal wisdom on that. I can't get too far from here with the clicker. So I started scripting all this. I touched anywhere from 1,000 to 1,000,000 files. I see how long it takes to list it at the file system level, just in a standard directory, take a peek and say, oh, okay, it takes about 10 seconds to run through 1,000,000 files. That is acceptable. And then I locally mounted an SMB share and simply ran the same test and found that, okay, about 50 seconds, listing a directory pretty much loop back mounted on the system. We're not touching the storage array much. I probably could have done this in RAM just to isolate the algorithms that are spitting out files. And I tried it on the LAN just across the room, like 8 feet away, and suddenly I'm getting like 45-minute to hour-long listings of the same directory. That's when things get a bit unacceptable to those with the electron microscope photographing the CPU wafers as they fly by. So I was pretty sure we had a problem, but step 2, you begin outreach. You think, hey, I think we have a problem. Hopefully I'm crying wolf, and I've been accused of that in the past, but I'm seeing this thing. So one client produced beautiful graphs, total geek. It's like, wow, this is fantastic. It's like, we have evidence, but of course, there are a lot of variables involved and various quotations that came out of this. The first of which was, I once had that many files, but never had a problem. And once is not a very precise computer science term. And perhaps it was back in the 9 series when everything seemed to work fine. And you didn't read the manual. And I confirmed that, well, there wasn't one. There's this tribal wisdom in someone's head. Fortunately, I had found all the elements of that separately through much searching. But okay, I know I went through those proper procedures. Also from a developer, so what's the fix? Like, well, I wouldn't be talking to you if I knew what the fix was, I'm sorry. And more or less, you're holding it wrong, as Steve Jobs put it. It's just like, So step 3, I was having some issues with icon. It is a UTF-8 thing, and all things UTF can be problematic. It was crashing VI, which is pretty impressive. I haven't seen VI crash in the last few decades, but suddenly they found a way to, and it was a GSOC program that was put into 10. I was like, this makes me a little nervous. Hopefully it's good code. And well, that wasn't it. So I started getting a little more scientific. I started running truss on the process as it's crunching away, listing anywhere between 1,000 and 1,000,000 files. And then finally, a developer thought, okay, I'll bite. I'll take a look. It sounds like you might have something based on the truss output. I could just tell that some of the operations made sense, some didn't make sense to me, but I knew it was doing more operations. So that alone suggested something. So moving forward, expletives deleted. Long story short, thank you, Ash, who's in the room. Thank you very much for taking the time to sit down with dtrace and figure out what's going on. But 9 months, really? Is that what it takes to just chase down one bug that I thought an afternoon would resolve? No. So, there must be a better way. So, shortly thereafter, another client is like, hey, OpenJDK isn't building. And so if there are two parts of third-party software I do not want to touch, it's Samba and Java. Just from my whole career as a Unix person from 91, I just don't want to go there. I'm fighting those actively. I'm trying to produce alternatives, so no. And so it's like, oh, great, we're building older software for Java, which is a complex beast. And there's this thing, poodle rare, poodle pair, poodle error, something, and the proper way to do that. But as you're transcending different points in history, that's a bit of a challenge because of all the little moving parts and their end of life and you name it. So my first conclusion is randomly setting up machines to randomly test random software is insanity. So, and of course, another quotation from developers, it builds on my box, bro. Anyone heard that in practice, How about a little professionalism here? So there is a bug somewhere between right now and the past. And in Unix, the past goes pretty far back. I started like there. I arrived when Unix was written in C, and then I was in college when FreeBSD 1 landed, graduated when 2 landed, and then, BSD was finally free, and it was like our code. It's not their code, it's our code. And then FreeBSD, the subject of this talk, has been churning along and producing various software. But I believe it was the OpenBSD folks who found a bug in Xorg, or back then X386. That was a good 15, 20-year-old bug, and it just sat there, and people suffered random crashes, but hey, you never know where that little problem will be. So in defining a scope, it could be anywhere, and there are various philosophies here where, yes, that's all fair game looking back in history, or the only version of FreeBSD that matters is the commit that just hit a minute ago and is visible on freshbsd.org. Go fast, go loose. Looking around at the Docker idea where you can reboot the Docker image so fast that you'll never know that you have a bug and the user won't know and just tear through it. Move on to the next project. So don't look back, bro. That works great if you never ever ship a bug or regression. But in practice, somehow people tend to occasionally ship a bug or regression, and looking at the releases pages, the software in question for this little issue is completely end of life. So officially it's not supported, and of course shouldn't have issues because, hey, lots of people pounded on it, but well, they missed this somehow. But this is open source. Absolutely all of the history is right there at your fingertips. This is not like going from NT 3.5 to Windows 2000 to Vista and finding some regression in there and then just thinking, oh, let's just go drinking. But you can actually chase down issues. They're right there. So let's go down this path. Let's build some infrastructure. First thing is a local SVN mirror, so you can check out any version of FreeBSD in this case at any point. Just have it right there at your fingertips, spinning on my little SSD. But that's an actual documented process. It's in the FreeBSD handbook. Go grab a snapshot of the SVN tree. I'll take small issue with the fact that the latest snapshot is from 2015. So once you retrieve it, you start updating it, and that takes quite some time and drains precious FreeBSD resources. So I'd love to see newer versions of those snapshots. And once you have that, you can sync it with base, as I mentioned, and then locally you can check it out. So if I want FreeBSD 5.0 release, I can just grab it from my machine and have it in a minute or two. And a point I'll just keep repeating is please keep those up to date, because suddenly having all that at your fingertips can be a very good thing in this context. So hitting the SVN web page, you can see all the release tags for all the releases. So they're all at your disposal. I learned that you generally will have a tremendously painful time trying to retrieve a release by the tag. You want it by name, but you can see what the most recent tag was, and that's a little forensics there. It's interesting. And so once you have this at your fingertips, you can interrogate it. So I started doing things like checking out a certain release. I package up that release in a familiar way and do simple things like run SVN info on it, which just tells me about what the actual tag is that's hiding in there for future use. And in interrogating it, which at this point, this is all automated. I just sit back and let it crunch away and look for stuff. Look for the dialog utility, look for SSHD, look for jail, look for virt.io, just look for stuff, all these neat things that arrived over the years. And then clean up the little result, the find results there, and see that, wow, okay, dialog, which is used by the installer, arrived in 205. SSH has been around a long time. Jail's been around a long time. At some point, we got like 64-bit support on Intel. And very nice things like OZFS arrived in 7, and then a bunch of key virtualization stuff, be it jail, Zen guest, virt.io support for really lightweight network and storage drivers, and of course Beehive come 10.0. Lots of great stuff, and the more things change, the more they stay the same. So these new things arrive, but that doesn't mean your whole existing paradigm changes a whole lot, fortunately. So I did a quick poll a few weeks ago and found that, wow, okay, so 71% of 49 respondees were curious about running, say, FreeBSD 5, because they either had a vendor-produced product that relied on something in that window. And thank you all who contributed. And I had to give little Savan a little nudge there because, hey, he's doing lots of old, cool systems. Please let others vote. No, I know you want old and cool and crufty and 4.4, you know, classic. You can do it. There we go. Okay, so for many reasons, FreeBSD 5.0 sounded like a great place to start. They just did some housekeeping, like moving the kernel to its current location, key point. And 64-bit came around in a pretty early FreeBSD 5 release. Beehive Load likes it. And of course, in the classic virtualization, FreeBSD 5 started sprouting jail management tools. Jails, lightweight, dare I say, containers, a lot like modern exciting things that have been around since about 2000. And these are all quite familiar, and familiarity will be a key point here. So I checked out to create a little tarball. The kernel's where it should be, and whoa there. I pledged long ago that I never want to see another floppy-sized chunk of the OS ever again. Thank you very much. And I was like, oh, I forgot about that. Right, okay, well, we'll figure something out. And there is ftparchive.freebsd.org, which does have old releases. It has several, not all of them. And I don't know if it's, like, say, backed up anywhere or mirrored anywhere, but that's a different conversation point. And so in all of this, fortunately, history is stationary when it's available. There can be some little gaps in history, as we know in any kind of history, but it's stationary. So let's start interrogating that archive. And so the first thing I did was craft a script to not hammer it too hard, but pull down things like CD-ROM images, but bring them down in the modern naming. That doesn't change their content any, but it makes them look like something generated today. Oh, attaching them, extracting their contents, repackaging their contents, and here's the tip of this iceberg, which is concatenating all those little floppy-sized files into a, in this case, gzipped archive, and then dropping in other components from the release into it, and on and on. And in that process, learning a lot about the history of FreeBSD release engineering and seeing how they rename stuff either permanently or for one release or moved it around or had 5.0-architecture-disk1 and then put the name FreeBSD in front and had a plural SHA-256 file in one release, or at least what's on the mirror there. Maybe someone was sloppy, I don't know, but you learn a lot of funny things. So through all of this, I'm avoiding violating the prime directive. I'm not changing history, I'm just pushing it around. I just want to bring all those little floppies into something more familiar. And so repack, rinse, repeat, and after a day or two of just pounding my head against that, I ended up with base.txz, source.txz, doc.txz, and these are all very familiar conventions. And I haven't changed the underlying software at all, but I have some pretty ancient software in software years, all in modern conventions. And it's a bit of a lie. I sat there watching it compress with XZ, and I'm like, okay, that's the majority of the time. I'm sitting on ZFS. It's a compressing file system with LZ4. It's very efficient. Why the hell am I doing that? So I lie to it and have a tar file named TXZ, let the file system compress it. libarchive don't care, it just does its work on it. So that was all a little simple nicety. Embrace the modern, and then take a breather. Okay, that was a lot of unpleasant hard work, kind of figuring out where all this stuff moved around to and all the corner cases. But suddenly, you can install FreeBSD 5 with the current BSD install. Because, hey, extracting an archive is not brain surgery. That hasn't changed much in decades on installing Unix, and so cruft be gone. Just streamline all that. So the principle of least astonishment, which I've heard brought up in various FreeBSD circles, is actually in action there. By not dramatically pushing stuff around at random, you get some consistency. And if you just sort of take the lessons learned and just push them back to the past, you get a smooth environment. So interesting facts. FreeBSD has supported NFS root since day one. It is Unix. That's how Unix works, and it's worked for a very long time. When your workstation just woke up and you didn't have like a ZFS array with terabytes, so you were relying on centralized storage. And so FreeBSD current can boot from UFS 1. And you thus have nice file and block options for these OS versions. So along the same lines, there's a project for NE2000 classic network card emulation. It appears to work. The Beehive E1000 emulation is quite good. It's not perfect. It could go a little further back, a bit like QEMU does. There's ATA emulation, and that is definitely broken and not going far back, and I can see what they did. I'm working with them on that. And there's AHCI disk emulation in Beehive that's been there quite a while, and that's quite useful for installing operating systems without virt.io drivers. You are welcome to interrupt me with questions if any of this is completely unfamiliar, and I wouldn't blame you if you haven't heard of virt.io and friends. So also, while Beehive is awesome, QEMU has been around a long time and has been lifting a lot of weight. And check your work in QEMU if you're doing things like building block devices. It will save you a lot of time in trying to boot it with your new nifty thing than having to fight it. Zen is in FreeBSD. It is absolutely underappreciated. Are there any FreeBSD Zen users in the room? Apparently has live migration and other friends, and let's give that some love. And VirtualBox is still around. There are a lot of options out there. Oh, and of course, Jail, which has been around for a very, very long time throughout this whole process, such that there are a lot of options here, and you've probably seen my talks on virtualization options. This keeps hopping back. So while FreeBSD 5 on a ZVol sounds pretty darn cool, I found that NFS is a little better for science. And nested VTX of Beehive and Beehive would be great. It took VMware like 3 years to have it quietly in the public just to get it proven with their massive development resources before they even trusted it as a technology. So you'll probably sense why this is an exciting aspect, but it's not quite there yet. So if you're asking, where is he heading with all this? So Beehive load can load FreeBSD 5 onward. Beehive load -E can feed in boot parameters. So in all of that, where I end up with all this sort of housekeeping I've been doing is to extract a userland and a kernel, just using the modern procedures. There's nothing exotic there. Add an FS tab, which is not very exotic. That's a standard where to find your disks on Unix. Adjust the TTYs to make sure the console works under Beehive, and share the results over NFS, and boom, FreeBSD 5 through current is at your fingertips. Any version is just right there to just hop into with very little effort once all this housekeeping is done. So back to those regressions. Those regressions are clearly hiding between releases, and building the OS is a slow procedure depending on your hardware. That ranges, of course, from is it a Raspberry Pi or is it an 80-core machine? But we're all familiar with, to some degree, what's involved with that. Fortunately, FreeBSD can be modularized with what's called source.conf. You can say, hey, don't build this modern giant thing, and you find yourself going a bit back in history. I started ripping out massive components, and I thought the results will be completely unfamiliar. Like, whoa, no, I recognize this. This is 4.3 BSD. It's like a real simple, lightweight Unix. There's no ZFS. There's no massive stuff. So that I sincerely appreciate about the operating system. And there are various ways to speed up the builds. Meta mode, Ccache, and if you're experimenting, it allows previously built items to not be rebuilt, which can save you a pretty big amount of time. A few months ago, I mentioned a student kernel, which I will get out there. And what it does is contain nothing more than what you need to both build it and boot it under Beehive. And there is something called a minimal kernel in FreeBSD, but that's very much not the same thing. And chopping down the world, like the kernel, can result in builds that are about seconds to minutes for each of them, depending on your hardware. So suddenly we've crammed what used to be like an afternoon of building stuff to potentially seconds. So in regression hunting, first define a test, define success. If you don't do that, you'll forget what you sat down to do because there's so many moving parts. Now, third-party software going back in time is definitely a pain. There were DVDs shipped by FreeBSD with binaries, and they contained things like Samba. What do you know? So they're actually your friend. And I didn't dive too deep into really old third-party software, but it's out there in various ways. And when you have 7,000 or so places to look for trouble, start in the middle. Work your way up or down, and just start having it. Start at 1933, go looking down, and work your way back. And if you hit the same problem, just narrow into it. And if you have to single-step revisions, do it. The machine will do it efficiently. And if you've chopped down the base and your test survives that, still works in it, we're talking a few seconds or minutes per revision. So I wouldn't suggest crawling through the entire history of FreeBSD, but it can be done. And it can be done in our sleep while the machine is crunching away at it. So in regression hunting, FreeBSD 9.3 will not build on 11.1. I learned that just in a quick test. It's probably a simple little change someone made somewhere, but you need to isolate your build. There's a classic, hey, builds on my box. Well, releases are your friend here. They're a nice point in time where you know they can build themselves. That's a huge step forward in all this. And I believe it's a project policy that FreeBSD N can build N plus 1 and N minus 1. Well, okay, so you want to get approximately to where you want to build target software and start there at least. And once you've isolated that build, so it's in a VM building whatever piece of history using whatever release from history that's appropriate for that build, put the results in a second VM. And then you have a clean environment to go back in time with. And so, continuing with that, NFS root is halfway to PXE booting. Well, aim this at your real hardware. I'm not sure your new, what's the new name? Your bronze machine will support FreeBSD 5, but you know, maybe you have hardware around the office and you can aim different Pixie-aware systems at what you're doing. So that's, you know, up to you if it's better to push those jobs out to other machines. So about that specific regression. Let's see, is everyone in the room here? One person here. So what was the term that was used? Optimized pathologic case of tell-deer. And here's the spot at which point that was resolved. Now, that's when it was resolved, but when did it appear and start impacting people? This was found the hard way, and by looking at SVM web, here's FreeBSD 9.3 and its tag. Let's look at the tell-deer code. I think we have an actual file name here. It is, oh, it's not there, it's a C file, but I followed it in the SVN and looked at when it was changed. And suddenly it's like, okay, the file is modified. Here's the path, libc gen directory 3 and gen telldeer.c. And someone, fortunately I can't read who that is, they did some POSIX compliance work, which is probably the right thing in many regards, but I don't want to beat up on it too much. So that took 9 months to find. I'd prefer that take, say, 90 minutes to find with a machine just crunching away at it and identifying that one commit that is making lots of users miserable. Because going into it, I was blaming Samba, I was blaming Icon, I was blaming a whole lot of things, and there's, again, got to be a better way, and there is the needle in the haystack. So moving on, a few lessons learned in all this. Regressions can live anywhere in history. Fast and loose is awesome, and don't look back is great, but sorry, they're out there. And when looking back in history, maintaining history is real easy compared to rebuilding it. Storage is now quite affordable. When there's an end-of-life release, just stick it somewhere. What used to be huge is now laughable in small size. And in software in general, just don't assume anything. So with infrastructure like this, let's think about questions to answer. I was hoping to get some answered by today, but I've been fighting all these historical little quirks, and thank you very much, engineers in the room, who have helped me make sense of some of the less documented, not for public use parts of FreeBSD. I very much want to chart simply which versions, which releases will build which other releases, and just create a chart of here's what you can do so that no one ever has to go through the trouble of determining that again. They just look it up and say, okay, FreeBSD 5 can build 4.3 through 6.1 or something. I wouldn't wish that upon anyone to do manually. How many parallel make jobs can you have for any given release? Nowadays, it handles them really well. Thank you for everyone who's done that. But with older ones, they'll simply blow up on you. And please reach out to me with questions on what you'd like to explore in history now that it's really easy to explore these things in history. Let's see, what else is there? So, thank you. I wanted to leave time for questions and ideas. Go a little interactive here. Thank you very much, VeriSign, for making this possible. And I hope to have something published somewhere by the end of this conference. I have all the parts working. I'm just lining them up to fire them off to answer some questions. Thank you very much for all the help you've all provided, and I'm sure I'll hit you with some more questions relating to these internals. But anyway, any questions?
So if you guys have questions, we've got these open mics to make sure that folks can hear. And the other reason I mentioned this is we are recording. And so we'll post recordings of presentations sometime after the conference, hopefully not measured in years. So if you have questions, I encourage you to go to one of the open mics.
Oh, come on, Dr. Keiki, you have a question? Anyone? Show of hands, who's using Beehive? About third of the room. Anyone using ZFS? ZFS? Wow, most people here, that's impressive. Jail? 75%. So a point I may have glossed over quickly was that FreeBSD 5 has both jail and Compat 4, Compat 3, Compat 2, and Compat 1. So depending on what question you want to answer, you have jail at your disposal throughout this, all of this history presented here. So if you need to spin up FreeBSD 2 under FreeBSD 5, which is at the moment easily provisioned, go for it. I dabbled with FreeBSD 4 and earlier, but that just takes some time and effort to push around the history, and there's some ABI issues, and you name it. And at one point, gee, A.out binaries and other ancient things. So if there are no questions, thank you so much. Oh, yes, sir. Yes, Scott.
So Michael, have you, can you talk a little bit about what you think of these technologies compared to, say, Docker? Assuming Docker were up to date and running healthily on BSD, how would it compare to some of what you've talked about this morning?
Okay, comparing to Docker in this infrastructure. If we look at that time scale of when all these features arrived, it briefly arrived on FreeBSD. I worked with a few folks to get it in, and then it's like, oh, that's the old Docker. No. And I guess Devin's working on some stuff. So it's not even on the time history yet. So for those 75% of the room running jail for perhaps over a decade, we've had awesome infrastructure for a very long time. To me, POSIX is the API. This is all shell scripting pushing around all these commands in the user land. I don't see why you would use another language to call a shell command or a utility at the command line. That's just how Unix works. And so there are ideas to steal from nifty new, be it packaging technologies, be it you name it, but I've heard quotations that Docker is like the DevOps approach to engineering because they can't touch any of the OS. It's like off limits. So they start running around all those limitations, whereas this community has been built on Unix for the PC, affordable hardware with true Berkeley Unix. So we tear down barriers rather than dance around them. So I've been repackaging FreeBSD since 5.0, making little jail VMs, and 5.0 had its issues, but I think I don't understand what problem they're solving because we've all been solving it for over a decade. It's like, so if that's my position on that, you know. And I haven't looked at the most latest Docker. Maybe there's some ideas or things we've been doing a long time and just aren't appreciated. You know, oh, repackaging an OS. Well, the OS has done that for decades. I don't see the problem you're solving. Yes, sir.
Having just written an article about Docker, I can tell you what they're solving with Docker.
Please, let's hear what Docker is solving. Yes.
They're solving the problem of how you push all your virtual machines into large-scale cloud providers where you're talking about not hand-maintaining one or two or a dozen machines, but thousands or tens of thousands of machines or instances. And it's about being able to leverage a small group of engineers to affect very large communities of virtual machines that aren't necessarily on the hardware that you have lovingly handcrafted yourself.
Okay, so
that's
for those,
what it's really about.
Hopefully you heard that they are making it easy to push a single stack, if you will, to thousands of machines in the cloud. I still see a user land and potentially a kernel that do some stuff. And back in Copenhagen, I believe it was, I asked PHK about how many jails can you run? And so he ran a simple script to just spin up extremely lightweight, bare minimum jails just to test the infrastructure. He got bored at 64,000. So that was 05, 06, I forget when Copenhagen your BSDCon was, but various folks have been pushing BSD to various cloud-ish, before we called it cloud providers, for a very long time. I guarantee there are lessons to be learned from the Docker approach. Absolutely. You know, if it's what people want, let's listen carefully to what they want and adjust accordingly. Where can that article be found? FreeBSD Journal. Okay, I'll check it out. Thank you.
Yeah, just to echo a little bit, and this is, I think it's a little bit out of scope for your talk, but one of the things that's interested me about Docker is, there's the point that you can deploy on a lot of machines. VeriSign has a lot of equipment around the world, and we have a relatively small operations team to handle this globally distributed footprint. So it's interesting to us. Really it's more about the orchestration piece. What can we do to manage these at an abstracted layer rather than down at the OS layer? And so that's why I say I think we're probably a little bit out of scope from what you were talking about, but that's kind of the evolutionary step. When you have the a well-functioning jails or Docker, how do you have an admin who maybe we reasonably expect an admin to handle 400 or 500 independent named hosts. Well, when you start deploying VMs and containers, that number could multiply by multiple orders of magnitude. So they get to the point where they have thousands of hosts to be responsible for, and their ability to cope with that environment degrades quickly. And so the orchestration pieces in Docker Swarm or Kubernetes are one of the reasons that it's piqued my interest. But like I said, what you've really addressed is kind of that building block layer that's sort of below the orchestration pieces.
Okay, so the question is the management of all this, and I absolutely appreciate that. First thing I'll say, I'm a sysadmin interested in kernels and file systems, if that's not obvious. But I'm using skills I used back in '03, and I walked away from Unix waiting for it to get things like Beehive and ZFS, and just walked away for a few years. All those skills are familiar again. It's like, oh, wait, I did this a long time ago. And to look at many of the OpenStack-ish management frameworks, the sheer amount of effort they spend dealing with dozens of Linux distros, potentially, if we're lucky, a few BSDs, and Windows, they're trying to abstract what to me is already really straightforward. So I feel we can already be a notch up in just having what is a familiar environment back to Berkeley in many regards. A few things moved around, and I undid those move-arounds, or at least pushed the modern conventions to them. So if we're in a strictly, let's just say, FreeBSD environment, that's been really consistent. So a lot of those just games, and the most frustrating part of Beehive for me is like trying to figure out how to install these damn Linux OSs. They put everything somewhere else. The install procedures aren't well documented because everyone knows how to do that. And they put date stamps in the kernels. Like, come on, how about we just look in boot/Linux VZ or whatever, and off we go. So I think we're in a position to step above that. I think it's been a major step backwards that desktop applications don't get much love. Web applications get a lot of love, but things like webmin still haven't changed since like 92 or whenever the heck it arrived. So I think that management should be open toolkits that are just as easy and familiar, because with the shell script, you just hop in and do some insertion. Oh, I need to log something just for debug, and I'll comment it out. I can do stuff in seconds that might take a complete recompilation of the Kubernetes beast, or you name it. But I think that's been the traditional gap of Unix and the pretty GUI. So I'd just like a GUI toolkit that has the monitoring plugin. I drop into a web interface and just, it'll be there once. I call it from a simple script, and off it goes. And management for listing VMs just gets stuck into a GUI. I'll take it from there, because once you orient yourself with everything here, it becomes pretty effortless. So Kubernetes sounds great. Kelsey Hightower is awesome. It is extreme nothing sacred territory, meaning no machine has any value to anyone. It just is a skeleton of a machine, and it gets flown down the highway at 100 miles an hour and then vaporizes when you're done with it. And oh, persistent storage, we don't talk much about that because everything's so dynamic and we just orchestrate it and high redundancy, which is great. Does Kubernetes support FreeBSD in any way, shape, or form, or another BSD in your research? And OpenStack has kinda, sorta, I guess, or Cinder drivers, maybe storage. Let's all stay on top of these technologies, but again, look at them as great sources of ideas necessarily before we just say, hey, let's just start a new lifestyle. Because if I were to hop between CloudStack, OpenStack, anything with stack in the name, and relearn them, I'd go mad. Whereas I'm using the same skills for decades, and that's served me well, and hopefully some of you. Any other questions? Wrapping up. Thank you.